In this episode, I want to talk about the new RBDOOM-3-BFG version 1.5, which is finally out after 1 year of development. I probably should apologize that this video is also 1 year after the last one, but I promise I wasn't lazy. This update is huge and replaces OpenGL with DX12 and Vulkan, using an abstraction layer API by Nvidia, and adds support for glTF 2 models and animations besides many other things. The new build took over 600 commits on GitHub, and we probably put something between 1200 or 1800 work hours into this to make it happen. So this is a team effort by 4 coders and different to previous releases. This is becoming more and more an international project, and this is the reason I want to continue this YouTube series in English. I want to cover only some of the new features in this release, or of this release, and not everything to keep this video short. I can only recommend to read the detailed release notes article on GitHub or Motibi of this version. Okay, so let's cover the installation. This is quite simple. If you want to download it from Motibi, then go to the main page, Files, look for RBDOOM-3-BFG 1.5.0 patch, and hit the Download Now button. If you want to download it from GitHub, then go to the main page and look for Releases on the right side. Click on the latest one and scroll down to the Assets section after the changelog. There you can get the same file and you can download the source code as well, but I don't recommend to download the source code. Just go for this on Windows, and if you're interested in the source code, then I'll make another video for it using Git on GitHub. Okay, once you have downloaded it, just open it and unpack it over your last installation of version 1.4. So in this case, if you watched my previous video, it is C projects DoomDev. Overwrite all existing files, and we're done. Now we can run the latest version. Before we continue, I have to thank Stephen Pridham, who did the major porting effort to Nvidia's abstraction layer Nvidia. I also contributed a lot to this by fixing a ton of bugs and making it ready for the public, but it wouldn't be there without him. Also, Stephen Saunders helped tremendously to get rid of the Vulkan related bugs and getting this running properly on AMD cards. So thank you both for all of this hard work. Stephen Saunders also contributed support for Borderless Fullscreen mode, which is enabled automatically if you switch from windowed mode to Fullscreen mode by hitting Alt-Enter. This has the advantage that you can run the source port along with TrenchBoom, Blender, Krita, or any other game dev weapon of choice, and it makes it easier to switch between the applications without messing up the desktop resolution. Temporal anti-aliasing is one of my favorite new features besides the better speed and simplified renderer backend. Usually, it is quite difficult to implement this because of the ghosting artifacts it can introduce. I have read many articles on how to get it working by many different graphics engineers, and actually most of them run into terrible problems with it. The good thing is that Alexei Panteliev by Nvidia provides a rock-solid temporal anti-aliasing implementation in the Donut Samples framework. He is also the maintainer of the Quake 2 RTX project, so if you haven't checked out that project, then you should also give it a try. Getting temporal anti-aliasing to work with his implementation was almost plug and play. It wasn't trivial, but I was lucky that Doom-3-BFG already had experimental support for motion blur, and I rewrote that shader to generate the motion vectors input, which is necessary for the temporal reprojection or color clamping. Color clamping is enabled by default, but this is how the game would look like without that feature. Physically based rendering causes much shader-based aliasing, which you cannot fight with traditional multi-sample hardware anti-aliasing. The old technique only works on the edges of geometries, but not within the shapes. I also have to thank Harry van Ginneken for his awesome glTF2 implementation. It wasn't enough for him to load models using that format, but he went all in and also made it possible to make maps with it. I helped him to get everything going, and especially with the map compiler integration. This is where RBDOOM-3-BFG completely stands out of all Quake and Doom engine source ports, because with this engine you can model maps now. However, this is for the advanced users who prefer to make the maps entirely in Blender. Beginners should stay with TrenchBoom. And of course, TrenchBoom has also been updated to support the new format. Last but not least, RBDOOM-3-BFG has better support for background music now. Like in modern Quake source ports, users can just throw their favorite soundtrack into the base music folder or into a mod folder, and as an example, I package the alternative Quake music soundtrack and you can run it as a mod. So for instance, just execute the batch file. Pick a map, and every map will play a different soundtrack. The music fades in. So, I hope you have fun with that. Enjoy it. In the next episode, I will go through the basic concept how you can subdivide and organize space using a BSP tree. And I will explain why it's still useful today. You will learn how it works, especially from an artist point of view, how you can optimize your maps with visibility portals for better culling, and how to reduce slide quit backing times with it. So, see you in the next video.